In this video, we are going to learn about the partial fractions, which involve repeating linear factors in the denominator. This is the learning outcome. If fx over gx is a proper fraction, and its denominator has a repeating linear factor with gx is equals to ax plus b raised to the power of n, then the fraction can be expressed as this. The examples are this. The first example only has one repeating linear factor in the denominator. Because the power is 2, so the partial fraction repeat twice, one with power of 1 and the other one with power of 2. The second example has two factors in the denominator. One is non-repeating linear factor and the other one is a repeating linear factor. So, the fraction is decomposed as a sum of three partial fractions. In this example, the denominator only has a repeating linear factor with power of 2. So, the partial fraction repeat twice. Multiply the whole equation with the denominator x plus 1 squared. Then multiply every fraction with this expression. Start from the left side. And we get negative 5x. Multiply the second fraction. We will get a multiplied by x plus 1. And multiply the last fraction, we will get only b. Now solve for a and b using substitution method. We substitute x equals to negative 1 first, and we get the value for b. Because there is only one factor, so we can choose any number to substitute. So I choose x equals to 0 because it is easy to calculate. Now substitute 0 into the equation together with the value of b, and we get the value for a. Then state the final answer. This fraction has two factors in the denominator, which are x plus 2 and x plus 3 squared. X plus 2 is a non-repeating linear factor and x plus 3 squared is a repeating linear factor. So this fraction can be expressed as the sum of three partial fractions. To solve for a, b, and c, we multiply the whole equation with the denominator x plus 2 multiplied by x plus 3 squared. First, we multiply on the left side, which leaves 3x plus 1 on the left side. Then, multiply this fraction with this expression. We'll cancel the x plus 2 and leave a multiplied by x plus 3 squared. After that, multiply this fraction with this one. We'll cancel the x plus 3 and we get b multiplied by x plus 2 and x plus 3. And the last one is to multiply this fraction with this expression and leave c multiplied by x plus 2. Now use substitution method to solve for a, b, and c. We substitute x equals to negative 2 first. And from here we can cancel out these two parts and we get the value of a. Then substitute x equals to negative 3. These two parts will be cancelled out because of the 0, and we get the value for c. Since there are no longer factors, so we can use any value to substitute. But choose the number that is easy to solve. So I choose x equals to 0. Substitute this value into the equation together with the value of a and c in green color. and we get the value of p. Now state the answer in this form. This fraction also has two factors in the denominator. X squared is a repeating linear factor and x plus 2 is a non-repeating linear factor. So the fraction is decomposed as the sum of three partial fractions. Now multiply the whole equation with the denominator x squared multiplied by x plus 2. And as usual, we will multiply on the left side first, which leave only 2x plus 1. Then multiply this fraction, we'll cancel the x and leave a multiplied by x plus 2. Then multiply this fraction, we'll cancel the x squared and leave b multiplied by x plus 2. And the last one, we'll cancel the x plus 2 and leave c multiplied by x squared. Now we substitute x equals to 0 and we get the value for b. Then substitute the other factor where the value is x equals to -2 and we get the value for c. After that, you can substitute any value. Since we already used x equals to 0 just now, so I choose x equals to 1 to substitute into the equation together with the value of b and value of c. So from this equation, we can get the value of a. To state the final answer, substitute all the values of a, b, and c into the partial fractions. But we cannot state the answer like this. We have to simplify it to this form. Please submit this exercise before class ended. Thank you.